So right now we're really focusing on studying these quadratic functions. They have that squared or that 2 for the degree. They make these beautiful parabolas. Last lesson, we looked at if it was written in vertex form, the way we can look at the graphs and the information there. There's another form we have called standard form. So think back to when you studied linear functions. You had slope-intercept form, standard form. There's also point slope form for linear functions. So kind of the same concept here with our quadratics. There's vertex form and then there's standard form. So standard form is f of x equals ax squared plus bx plus c, where a, b, and c are all real numbers, and then our a cannot be 0. Think about that. If a is 0, 0 times x squared would make 0, and this is no longer a quadratic function. So all of that is just extra information there for our definition of standard form. For example 1, we're going to graph the equation y equals x squared minus 6x plus 5 on the set of axes below. Now on Delta Math, these are the literal directions from Delta Math. You have to plot 5 points and only 5 points. Delta Math will not let you plot a 6th point. Of those 5 points, they have to be the roots and the vertex, and then maybe 2 others. So remember our roots, that vocabulary is our x-intercept. So when we get there, I'll show you. Step 1 to graph standard form is to find the axis of symmetry. So there's a little baby formula for axis of symmetry, x equals negative b over 2a. This is going to be the center of our parabola, literally the middle of the symmetric shape of our parabola. So let's look here at our function that we've been given. We have an understood 1, x squared minus 6x plus 5. So our a is 1, our b is negative 6, and our c is 5. So as we plug into this formula, we have negative. The b value is a negative 6 over 2 times a, and a is 1. So simplifying, we've got positive 6 over 2, or our axis of symmetry is 3. Let me show you how that looks. Here, I'm going to draw a vertical axis of symmetry. Our parabola is somewhere along that axis of symmetry. Step 2, we're going to find the vertex. To find the vertex, we're going to plug in that axis of symmetry value that we just found, 3, into our quadratic function so we can find the y coordinate of our vertex. I already know my vertex is 3 something. Literally, the x coordinate has to lay on this axis of symmetry. So let's plug in. I'm going to rewrite the function down here so we know exactly where we're plugging in. We have y equals our x value is 3 squared minus 6 times 3 plus 5. Simplifying, I've got 9 minus 18 plus 5. 9 minus 18, negative 9 plus 5 will give me negative 4. My vertex is the negative 3 that we found from the axis of symmetry, 3, negative 4. So plotting over here, here's my vertex. 3, negative 4. And from what we've studied already, my leading coefficient is positive, so I know this is opening upward, so that vertex, 3, negative 4, is going to be my minimum or my lowest point. Step 3, plot the y-intercept if possible. So from our function y equals x squared minus 6x plus 5, your y-intercept is always going to be your constant. So in this case, we have positive 5. And because parabolas are symmetric, I could plot the reflection. We're over 1, 2, 3 from the axis of symmetry. Let me go 1, 2, 3 out. I can plot that symmetric point there on the other side. Step 4, you can use what's called the 1-3-5 rule. When I first started teaching in graphing quadratics, I would tell students, okay, now let's keep plugging in x coordinates so we can plot more points and then we can reflect them. 1-3-5 is actually a much faster and simpler rule to use. It says we can take 1-3-5 and multiply it with our a value to get kind of the slope or the shape of our parabola. So we'll do 1 times a, 3 times a, 5 times a. Our a value was an understood 1. So 1 times 1 is 1, 3 times 1 is 3, and 5 times 1 is 5. And so that's going to tell us how to move to find our next point. We're going to go over 1, up 1. And it's always over 1. So on 3, we're going to go over 1, up 3. and over 1 up 5 should give us kind of our shape of our parabola. So this is a very simple, basic shape here. So let's start with over 1 up 1 from our vertex, over 1 up 1, and you can do that from either side because it is symmetric. And then over 1 up 3 from there, over 1 up 1, 2, 3, hitting right on that axis. And I'm also reflecting there. So looks like we've got a very good shape. I'm going to do step number 5. I'm going to graph my parabola, just connecting my points. And then let's recall what we said about the directions. Delta Math says we can only include 5, and they have to be the roots and the vertex. So let's highlight here. When I graph it, I have to include this vertex point and these 2 roots or x-intercepts. You can pick the other 2 points that you want to use, but we have to have those 3 specifically, the vertex and the 2 roots, and then you pick another 2 points to plot there. Example 2, graph the equation y equals negative x squared minus 4x plus 5 on the axes and include 5 points, including the roots and the vertex. No change in our directions there. Only 5 points are allowed on Delta Math. Going to model that here for you. Now, it is really, really important for you to understand how to graph a parabola without a calculator. There will be some parabola graph questions in our non-calculator portion on our benchmarks, and therefore I assume on your EOC as well. So make sure you are comfortable with the graphs, at least finding your axis of symmetry or plugging in some points, and we'll look at some example benchmark questions as we get closer to that. But let me show you how you can graph it on the calculator. So let's grab that calculator and let's graph number 2 using our calculator. So from your home screen, you definitely want to always use a new document. We are going to add a graphs page. When you open up a graph page, it's going to start with f1 of x equals. Essentially, this is saying y equals, and we're ready to rock and roll. So I still have it shown here on the screen. We're doing negative x squared minus 4x plus 5. I'm going to go ahead and hit enter to graph it, and I can see that beautiful parabola. I'm going to turn on my grid lines just so I can see those as we're looking at this. Menu view is number 2, 6 is grid, and 3 is lined grid, so I can see those x and y coordinates a little bit better. On our calculator steps, here on our notes, to identify ordered pairs on the graph, you might want to use menu. Number 7 is table, and 1 is split screen table. So this is literally going to give me an x and y coordinates in a table form. Look here on the left side. This is our x column. So negative 1, 0, 1, 2, 3. Those are x values. And these would be the y values, 8, 5, 0, negative 7, negative 16. Let's find some easy points to work with here. I do know we have a negative leading coefficient. That negative 1 x squared is going to turn it upside down and it's opening downward. So I do have a maximum point, and I believe I found it at negative 2, 9, because I can see that symmetric pattern, negative 3, 8, and negative 1, 8. So let's use that information to plot these points on our graph. We had negative 2, 9, negative 1, 8, negative 3, 8, 0, 5, and negative 4, 5. Now I've plotted 5 points. This is not going to work on Delta Math because I have to still include the root. So we got to find out where it is hitting our x-axis. Let's go back to our table. So I'm looking for a y value of 0. Y value of 0. Oh, there it is. 1, 0. And I bet if I kept going up, we would have saw the same thing. Negative 5, 0. So there are my roots, negative 5, 0, and 1, 0. So when I go to graph this one on Delta Math, what do I have to include? The vertex and the roots. I have to include 5 points total, but they have to include those 3, the vertex and the roots. So here's my parabola. So you have to do those 3, and then you could pick the other 2 that you want to use. If you're ready to close the table, you can go to Menu, Table, and Remove Table. And it'll go back to that original view of your graph. Another feature a lot of students really prefer instead of the table is under Menu, Trace, graph trace, this is going to put a cursor on your graph, and you can scroll left and right to move that cursor. And as it moves along, it is going to identify those essential points like your x-intercepts, your roots. They're also called zeros. So we do see that 1, 0 identified there. If I travel up, I'm going to see the maximum point was -2, 9. It also highlighted our y-intercept along the way. And then I can come back and scroll over here to our left side, the root or the x-intercept, -5, 0. The only tricky part is sometimes the trace tool doesn't identify enough ordered pairs for us. They are going to show us those roots and the x-intercepts, the y-intercepts, and the vertex. But if you needed another point, it doesn't always give us another pretty point. See how I'm moving along, and it's got decimals, 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 decimals. There's -3, 8. So a lot of students do prefer this trace. Again, that's under menu, number 5, trace, graph trace. A lot of students end up using that. When you're done with that feature, you can just hit escape to remove that. On our notes, we also talked about how to reopen. Maybe I typed this in wrong, or I want to check what I wrote. You can look at tab, and then it's ready to open up your next graph, but arrow up, and you can look and check how you typed in that first function. If you're ready to start a whole new graph, what I would recommend is either Control I to open a new page and start a new graph, or you can do Control Dock, which is going to do the exact same thing, open a new page where you can open a new graph. Notice how I had 1.1 tab, 1.2, and 1.3. I can travel between those tabs using Control Left and Control Right, but going back left twice to see that original 1.1. All right, I think that about covers it on our calculator. The last couple of examples are multiple choice from Delta Math. Number 3, we're looking for the equation that best matches the graph shown. I know this is a smiling, opening upward parabola. So I know that my A value has got to be positive. So let's look here. Looks like these left ones are out because they are negatives. Those would both create a negative frowny face parabola. So A and B is what we'll call them over here. A and B are still leading in the race over here. What other information do we know? I know on my y-axis, it is crossing at about -7. And I'm seeing that there. I'm going to just double check. Nope, it looks like it's crossing right at -7. There are some on Delta Math that are a little close because notice our other answer choice is -7.3. But usually they're very obvious there. So this top left answer choice is our best answer. Just knowing our A value is positive, so it's opening upward, and identifying our y-intercept, which is always our constant in that standard form. Let's look at number 4. Same thing, but it's frowny, so A has got to be negative because we are opening downward. So again, the right side are out because those are positive. I need negative leading coefficients. Identifying our y-intercept, it is crossing right at -6, not a positive 9/10. So I think we found our final answer is this bottom left one, y equals -9/10 x squared minus 5x minus 6. So just using a little bit of information with these. So just using a little bit of information, but these are written in standard form, we're able to answer these multiple choice questions on Delta Math. So again, right now we're studying quadratics extensively. We've already looked at vertex form. This is standard form, ax squared plus bx plus c, which is actually how you're probably going to see quadratics most of the time. We looked at graphing it by hand, which is important to understand for those non-calculator sections when we're asked about questions of our graphs of quadratics. But I did show you how to graph it on the calculator with some tools and features there, so you can use that through your lessons and through your quiz this week. And then matching with multiple choice, super, super easy. You shouldn't be typing those into the calculator. We're just looking at the A value at front, if it's positive or negative, and then the C value or the constant in that quadratic function is going to be our y-intercept. So very easy to match there. Guys, let me know as you have questions. We'll be practicing in class, and I'll see you there. Bye.